Moving on to how safe is Barbie? Let's talk about that. You think she's not very safe? Really? Already?
She's never safe.
Barbie's never safe. Okay. So how can we be sure that the bungee cord that we make her is safe? All right. Should we be worried that you used the wrong units or the wrong axis, or we maybe even measured wrong? So let's look at our data. Here's one group's data and their scatter plot. What is wrong with their scatter plot? No labels, first of all, right? So it needs to be labeled, number of rubber bands, and the distance of the fall with units, right? That's a C, looks like an O, in centimeters. Is it inches? Did I read it wrong? It is inches, thank you. Guess the other one was in inches, thank you. What else is missing?
The line that fits, do we have to draw there?
Not yet, we're not there yet. Well, we don't have a dot at 2.
Yeah.
Where should it be? At 17. What about at 4? It should be up at 22, right? So it's a little bit incomplete, but not hard to fix. Now, if you were writing your sentence to describe this thing, what would you say? Association. You can say relationship instead of association. Between number of rubber bands and the distance fallen is what? Positive. Linear. Strong. Anything unusual? Okay. Is positive. Strongly linear. With no unusual features. Okie dokie? Yeah. Yeah, if you did see something unusual, you would point it out. Like there's an unusual feature at, let's say 12 rubber bands, it only fell 15 inches, that would be unusual. You would specify what it was, yeah. But we haven't had one like that, I get that. Okay, so now it says run a regression on the data. This is something you may have done in algebra, I don't know. But yeah.
Sorry, if there's like an outlier, would that like make it like moderate?
Well, we're getting there. It depends on where that outlier falls. It's coming. Good question. It's coming. So R is a big, hairy calculation, nasty formula. When you watch the video, I'll show you the formula, and you'll be so thankful your calculator does it all for you. All right? It will calculate what that R value is, but you have to tell it what is X and what is Y. So you have to enter the data like into list 1 and list 2. Now, we're not going to stop and do it now just for sake of time, but we'll do it eventually, okay? List 1 and list 2, if I put it in there, and then once my data is in there, I'm going to go to Stat, Calc, and you're going to look at number 4, and it says Lin Reg, like linear regression. All right? And in the output, we should see an R value. All right, so what it's giving me here is this equation. So here's the structure. A would be my slope, right? B is my y-intercept. Now, R squared is a value that does matter, and we are going to talk about it after spring break, I think. But it does matter. R is the one we're looking at right now. That's correlation, okay? So it has a correlation of 0.99. Now, here's the thing about correlation. It's always going to be a decimal or a value between 1 and -1. 1 would mean it's a perfectly straight positive slope line. -1 would be perfectly straight negative slope line. Everything in between is valid, right? Every decimal between. So if it's really, really weak, it'd be like 0.0002, right? So this one has a correlation of 0.99. Now, in your calculators, we'll work towards this. You got to have a couple features turned on, but we'll make sure you have it before we get there, okay? But notice it's all done for you in the output. Now, that being said, we said that this is 0.99, right? Now, based on that, it's a measurement of how strongly linear is the data. So based on that, how safe would you feel Barbie's bungee jump would be if we use the data to predict how many rubber bands we really need for the whole fall? You feel safe? Seems like a good predictor, doesn't it? Okay. Since R is close to 1, it seems like predictor safe to predict is what we're saying, right? Now, let's say one of the group members snuck in some extra rubber bands to collect more data. So use, it says add the point 15 rubber bands and 49 inches to our scatter plot. So 15 rubber bands, 49 inches would be way up here, wouldn't it? So definite outlier. Do you think it's going to strengthen the R value or weaken it? Remember, R is a measurement of how closely it resembles a line. So does it fall in line with the other data?
Yeah.
It does, doesn't it? So this would strengthen our R value, okay? So it will strengthen the correlation because it falls within the form, or you could say the form or the pattern of the data. Then it says, okay, another group member accidentally left off a digit. So change the 0.66, the one that was at 6, change to 6.6 instead of 6.26. So this point that's right here, nope, that's not it. This point that's right here is not supposed to be there, it's supposed to be way down here. Okay, that's an outlier. What is it going to do to our R value? Weaken it. You see it? It's all about the location of your outlier. If it falls within the form, it's going to strengthen R. If it falls outside the form, it's going to weaken it. So it's going to weaken the correlation because it falls outside the pattern of the data. Okie doke. All right, last little curveball to throw at you. Unfortunately, the group had measured the lowest point of Barbie's head in inches instead of centimeters. That was the directions to do centimeters. So to fix this, they took the distance in inches and multiplied all of them by 2.54. What do you think this did to our R value?
It should still be like roughly the same.
It should stay the same, right? Kind of like back when we did means and standard deviations. Multiplication didn't, I mean, it changed it, but didn't change the shape, right? Same idea here. Same idea here. It's not going to change our R value. Will not change it. So it will not change R at all. Okay? Okay, let's summarize this stuff about R. Now, sometimes you're going to be asked to interpret R, just that value of R. Like, I'll give it to you or you'll calculate it. It says to interpret it. So you don't have to do duffs or doffs on that, but there are a few things that you do need to include. You need to include direction. It's either going to be positive or negative because it's either positive or negative number, right? Form, get this, the form is always linear. R is a value that measures linearity, so it's always linear. So strength, as you can imagine, goes from a scale from -1 to 1. -1 would be a strong negative, right? Just like a positive 1 would be a strong positive. And what would 0 be? Weak. It would be super weak, right? What'd you say? Neutral. And then everything in between, like you can gauge it. Like if it's 0.8882, something like that, that's kind of strong, yeah. But if it's 0.52, that's kind of moderately weak, right? Use your words wisely. Always use context. And so use ly words. In English, we call those adverbs, right? Moderately weak, strongly linear, weakly linear, something of that nature, okay? Then we did the properties of R. We talked about this. If you have an outlier, an unusual value, within the pattern, what did we say happens to R?
If it falls in the pattern, it strengthens it.
In the pattern, so it's going to strengthen R. If it's not in the pattern, it's going to weaken R. Got overgrown bullet points here, but it's all right. R does not have units. So if you ever see an R value reported to you with centimeters per rubber band, it's wrong. No units, okay? And then if you accidentally, confused your X and your Y values, like if you got your explanatory response variables messed up in L1 and L2, the R would not change. It doesn't change. The way the equation works out, it's going to be okay. Nice little feature, all right? And then this is what we were just saying. If we just divide by something or multiply by something on one, it doesn't change your R. And then the last thing, correlation does not equal causation. All right, so here's the thing. That sounds pretty easy to understand, right? Just because two variables have a correlation doesn't mean one causes the other. And that makes perfect sense, right? Okay, I already know that. But what they try to do is throw you some scenarios of hey, there's a correlation between the temperature and ice cream sales of 0.99. Does that mean the hotter it gets, the more ice cream is going to be sold? Does the temperature cause the ice cream sales to go up? No, you can't, even though it might make some logical sense, you can't say cause. All right, so be careful for the word cause. The only time you can use causation is when you've done a hypothesis test on an experiment, okay? Correlation can be calculated between any two numerical variables. If we have time, I'll show you this goofy website out there, someone who's correlated all the weirdest things in the world that have really high correlations, but one does not really affect the other. It's bizarre, but I'll show you. Now, so this one, here we go. Scatterplot's done, no worries, we don't have to make it, okay? So here it is, fueleconomy.gov gives the city and highway fuel economy for all makes and models of vehicles back to 1984. Scatterplot displays the city and the highway fuel economy for a random sample of 10 2021 vehicles. There it is. All right. Correlation between the city and highway fuel economy for these vehicles is 0.917. They gave it to us. Now it's asking us just to interpret that. All right, that's that first bullet point thing we need to do. We need to do a direction, call it linear, and give it some strength, okay? And always have context. So we could say the association between city and highway fuel economy is, what would you say here? Positive? Linear? What about strength?
Strong.
0.9?
It's close to 1. That's pretty good.
Right? 0.9 is pretty close to 1. So I would say is strongly linear and positive. As long as you have those features in your sentence, it doesn't have to be exactly like mine. Direction, strength, linear, and context, right? All right, B, if the fuel economy was measured in feet per gallon, not when you're doing R values, only if you're doing the scatter plot. So if fuel economy was measured in feet per gallon instead of miles per gallon, how would that affect the R value? It doesn't. That would be terrible, right? It would not change the R value. Changing units has no effect. And then lastly, it says the Rolls-Royce Ghost, EWB, gets 14.4 city miles per gallon and 25.5 highway. What effect does this point have on the correlation? So that's this point way down here. Kind of an outlier, but what can you tell me? What is it doing to the correlation there?
It's in the data pattern.
Yeah, you got to ask yourself, is it in the pattern with the rest of the data?
Yeah.
Roughly? Roughly. We're not perfect here, remember? We're stats. We're just roughly, we're approximate, everything. It's within the pattern, so your logic would be it would strengthen R. Okay? It would strengthen it. It would make R closer to 1, or you can say strengthen. Either way is fine. Because it falls within the pattern of the data.